So anyway, moving on from parts of anatomy back to mathematics. So here's what we have. Because I don't feel like teaching, we're going to break this lesson into 2 days, okay? Because that's where I'm at as a teacher. No, we're going to do a little bit of statistics, and then we're going to review, and then tomorrow we'll do a little bit of statistics and then review. I don't know. Depends how long I take with the statistics. All right. So this says, a survey of a sample gathers information from a few people, and then the results are used to reflect the opinions of a larger population. The reason that researchers and pollsters use samples is that it is cheaper and easier to poll a few people rather than everybody. One key to successful surveys is to find the appropriate size for the sample that will give accurate results that reflect the larger population without spending too much time or money. So you'll notice that every so often when they're trying to come up with statistics about Americans, they'll do like a census where they're trying to get information about literally every single person in the United States. And they send out all these things that people have to fill out, but they don't do that every year. Why do you think they don't do that every year? It's not cost effective. A lot of people have to be chased down to give the information. A lot of people don't just like do it and turn it all in on time, yada, yada. So it's a lot easier to take like a sample of the whole population and get information about them because that's more realistic. You can do it in a timely manner, whatever. And if you have enough people, it's still pretty representative of the whole population. It's just like not as much of a headache. Okay, so when we look at this, a population is the entire set of things or people. And when we've been talking about the mean and standard deviation, we've actually been using the mean and standard deviation for the population. So mean is that mu, and standard deviation is that Greek letter that I still haven't looked up. Sorry, I can do that this period. So these are called parameters of the population. So the word that you use to describe the mean and standard deviation, you say those are parameters that you found. Those will be true for the entire population. All right. And the population could be any like group that you're talking about. So maybe I want the population to be this classroom. Then my sample could be like a few students in this classroom. But the entire population would be all in this classroom. Or I could make my population bigger and say that my population is all of the whole high school, and then a sample could be like a few different classes within the high school. Okay, so the population is the entire set of things or people. We talk about parameters when we give a name to the data that we get from the population. When we talk about a sample, that's a subset of the population. And when we get the mean or standard deviation from the sample, we call that a statistic. So it's a statistic if it comes from a sample. It's a parameter if it comes from the population. You hear statistics a lot, I'm assuming, because most of our information comes from a sample, not a population. So the mean is, we call this X bar. It's an X with a bar over the top. Ah, you're like, I've heard that before. No. Standard deviation.
No, I was just saying that because...
Oh, you like it?
It's called X bar.
Yeah. Standard deviation is X, or is S. I've seen the S with a sub-X before, but not always. And more recently I saw it as just S, so we'll say S for standard deviation. So that's a good time. So we get our variables in English this time, which is always fun. All right. And that is all of the notes that we're going to do today. No, I don't feel like doing anymore. I don't. I'm not even 5 minutes in and I already feel exhausted. Yeah, let's start the practice assignment. All right. So, as I was saying, are you ready? All right. This says, of all U.S. kindergarten teachers, 32% of them say that knowing the alphabet is an essential skill. I'm very concerned that it's not more than that. Is that a statistic or a parameter? Parameter. It's a parameter because they said all U.S. kindergarten teachers. That's all of them. Not a few, all of them. I'm concerned about that as well. Of the 800 U.S. kindergarten teachers that were polled, 34% of them say. So that's a statistic. Okay. Of the entire U.S. adult population, 36% have an allergy. A sample of 1,200 randomly selected adults resulted in 33.2% reporting an allergy. What is the population?
The U.S. adult population.
Okay, so all U.S. adults. What's the sample?
1,200 adults.
Okay. What is the statistic?
33.2%.
Or some ice cold water poured over your head. I can't get you to the play, but I can get the ice cold water for you if you want.
I'll go get it.
Oh no, I got some right here. Nah. I don't trust any of you guys today. No trust, but nobody's going to the bathroom today. Or if you go, there's a 60-second rule. You gotta run, go, come back. All right. What? No. What is the statistic? And by that, he meant 33.2. 33.2% of adults with an allergy of U.S. adults. What is the parameter? 36%.
Because Russia is an awesome place.
All right. So, in your own words, you're going to explain why a parameter is fixed, which means it can't change. It's going to be the same always. And a statistic would vary. A parameter is fixed. A statistic is going to vary.
Okay.
It might be easier to explain why a statistic will vary first, and then that can help you figure out why a parameter is fixed. No one would ever know you were in this room.
I was great as a mouse.
A squeaky mouse. Because he squeaks a lot. Because you can control if you squeak. Yes, you can. I guarantee, when you are a 35-year-old man, you will not squeak anymore. You will stop squeaking, which means that you are in control of your squeaking it just kind of fits your vibe in high school right now. It fits you a little bit. So, but there's a point where you will be like, I am a grown man. I'm not going to squeak anymore, and you will stop squeaking at that point. Yeah. I will have to go back and replay some of our tapes. Okay.
Is my voice gets really high pitched?
Yeah. Yeah, you just did it a little bit. You said I do, but you kind of squeaked at the end of it. Yeah.
Let's talk about something you're interested in.
Yeah, that's true. That's true. Get excited about something and the squeaking will happen. All right, so as we were saying, back to math. Someone explain to me why a statistic would vary, why it would change. Yes, Lily.
I just read out everything that I wrote.
Yes.
Okay. It said a parameter is the 100% which can't change. The statistic is a percent of the 100% or whole that can vary.
Yeah. So the statistic would be dependent on not the parameter.
It's different because I don't know how a statistic will change because biases, but I know that's not right.
No, so a statistic and parameters are both describing mean and standard deviation. They're both describing the exact same thing. But a statistic is talking about a smaller sample of people, and so your statistic could change if you sample, like maybe my sample one day is girls and my sample the next day is boys, and that those percentages for my answers are probably going to change based on that, which is kind of in relation to what you were talking about bias. Or it could be I checked with, I'm going to stab you guys with that pencil, or it could be that today you sampled 3 people on this side of the room and tomorrow you sample 3 people on that side of the room and the statistic is slightly different. The parameter shouldn't change because that population should have the same thing true about them at all times until the population changes, right? So if we're talking about the U.S. population, by tomorrow we're going to have more people in the U.S. because babies are going to be born, you know, and maybe some people are deported. Awkward. So the population could change day to day. You know what I'm saying? But as far as like the population at that moment in time, the number is the number. The mean is the mean, the standard deviation is the standard deviation, whereas with a statistic, that talks about a sample and the sample could change. All right, so what you're going to do today is you're going to work on this. Now, this needs to be finished by tomorrow. I also want us to work on the review. I think this would be a little bit easier to do on your own than the review would, to be honest. So I would say maybe finish the first page, like get to number 12, and if you're feeling good about it, put this away and save it for at home, and then let's just work on the review in class, is kind of what I'm thinking. Sound good? Okay.